Hello, boys and girls. Welcome to another marvelous manatee math movie where you get to play the role of the therapist and solve all of math's troublesome problems. Today, we're going to be covering the third section in chapter 1 in your book, which begins on page 25. Our topic is going to be distance and midpoints. You will need your notebook, you will need your book, and this could get a little bit lengthy because we have a lot to cover, but we'll do this as quickly and efficiently as we can. So without further ado, let's get started. A couple of words that you're going to need to know for the section. The first one is distance, which is the length of the segment between two different points. Irrational number is a number that you cannot express as a terminating decimal or as a repeating decimal. The midpoint is the halfway between the two endpoints of a line segment, and a segment bisector is any segment, any line or plane that intersects a segment at its midpoint. Take those down and get those definitions down, add the rest to your glossary. There are a couple formulas that you're going to need to know. The first one is the distance formula. I would write this down. You're going to be using this a lot this year, so write it down now and eventually commit it to memory. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And we will be using that today, so you'll be needing that. Make sure you get that down. The other formula that we'll be using today is the midpoint formula, and we're going to be using this to figure out where the midpoint of a segment is. This is x1 plus x2 divided by 2 and y1 plus y2 divided by 2, and you'll notice that this is kind of looks like an ordered pair because they're in parentheses. So once you were to solve this, you would have an ordered pair, an x coordinate right here and a y coordinate over there. Alright, here's example number 1. They do give you a formula for it, but this is super easy, so I'm not even going to bother with the formula right now. They want you to use the number line to find the distance between B right here and E. And so the way that you could do that is you could do negative 6 minus 2, which would give you negative 8, and it would be the absolute value of that, or 8. The other way that you could do it is simply count. 1, 2, 3, 4, 5, 6, 7, 8. So your answer would be 8. The on your own for this one, I'd like you to figure out what is the distance between AC, the distance between CF, and the distance between FB. Alright, take a second or two to figure out what the distance is between these 2 points. Alright, between AC, you have 1, 2, 3. Between C and F, you have 9. And for FB, you have the greatest amount, 11. Not too hard, trust me, it does get a little bit more complicated from there, at least a little bit. Alright, so this is going to be example number 2. And example number 2 says find the distance between C, which is at negative 4, negative 6, and D, which is at 5, negative 1. So when you read this problem, you'll see that you're finding the distance. And what that means is you're going to be using that formula that I gave you a couple of minutes ago, and hopefully you wrote down. To find the distance, the formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then what you're going to do is you're going to assign either C or D to be x2 and y2, and the other one will be x1 and y1. So just to make this simple, let's make this one x1, y1. Let's make this one x2, y2. And it doesn't matter which one you choose as long as you remain consistent throughout the whole problem. Okay, you cannot change it once you start. So I'm going to shrink it here because I'm going to need a lot of room in order to do this because it does get quite lengthy. So let's start first with our problem. We need our square root. Okay. And let's see here. There we go. It did show up eventually. Now we're going to start plugging in numbers. x2 is going to be d over here. Remember this, we're going to say this is group number 2, this is group number 1. And so the x of group number 2 is 5. And so we're going to put that in for right here. Then we have to minus x1, and the x coordinate in group 1 is negative 4. And so two negatives, right? If I minus a negative, that actually becomes a plus 4. Don't forget your squared. And you have to add that to y2, which is negative 1. And then we're going to minus the y1, which was negative 6. So again, because I have the negative in my formula and the number is negative, that's going to be two negatives put together, which changes it to a positive. And then we get 6. And don't forget that that is squared as well. Alright, let's move down another step. 5 plus 4 is 9 squared, plus negative 1 plus negative 1 plus 6 is 5 squared. Getting smaller and smaller here. Now we just need to continue solving. The square root, 9 squared is 81 plus 25. 81 plus 25 is the square root of 106. And that is not a perfect square root, so you can leave it like that. So the length of CD, or the distance between them, is the square root of 106. Not too bad, right? I hope. It's just using the right formula, plugging the numbers in, and then making sure that you're not forgetting to add as you go. Alright, here's one for you to try on your own. You need to find the distance using the formula we just used. To find the distance between E, which is at negative 5, 6, and F, which is at the point 8, negative 4. Here's where you pause the video and you work it out on your notebook to see if you got the right answer when you unpause it. Do it now, please. Alright, this is the way that you should have set it up. I chose this one to be my x2, my y2, and E to be my x1 and y1. So your formula is x2, which is 8, minus your x1, which is negative 5, squared, plus your y2, which is negative 4, minus your y1, which is 6, and you have to square that. Once you're here, you can begin to solve your problem. 8 minus a negative 5 gives you, don't forget your square root, a 13. Negative 4 minus 6 gives you a negative 10. 13 squared is 169. Negative 10 squared is 100. And lastly, we add these two together and we get the square root of 269. Now that's not a perfect square root, but if you do put put it into a decimal, you're going to find that it's around, not exactly, but it's around 16.4 units. So this right here should be your answer. Not too bad. Really, the hard part is just remembering the formula and then plugging in the numbers and then performing the operations. As long as you do that, you'll be all right. All right, now we're going to quickly cover example number 3, and I'm going to read this out of your book. It won't be up here, but you should have your book so you can read along. This is example number 3 on page 27. And what it says is, Jacinta hangs a picture that's 15 inches from the left side of a wall. How far from the edge of the wall should she mark the location for the nail the picture will hang on if the right side edge is 37.5 inches from the wall's left side? So what it's looking for, it's asking, is for the midpoint. And here you'll see that I put half of the midpoint formula up there. What we want is we want to use the 15 inches that it needs to be from the left side of the wall. And then we're going to add, there's 37.5, and then the rest of the formula is to divide by 2. When you add 15 plus 37.5, the answer that you're going to get is 52.5 divided by 2. And when you divide that by 2, you're going to get 26.25. So what that means is that the midpoint, or where she should put the nail for her wall, should be 26.25 inches from the left edge. And that covers example number 2. Example number 3, we're going to move on, and we're going to be doing some midpoint. Alright guys, here we're going to be example number 4. And this is finding the midpoint. You're going to find the coordinates of M when the midpoint of ST for S, when S is at negative 6, 3, and T is at 1, 0. So just to clarify, these are coordinate planes, so you would go from the origin left 6, up 3, and T, you would just go to the right 1, up and down 0, and plot those 2 points, draw a line, and you're trying to find out where the middle of this line is, this segment rather. To do this, you're going to need the formula that I put up earlier. It's called the midpoint formula, and the midpoint formula is M, which just stands for midpoint, so we know that it's midpoint, and that was retarded, so I'm not going to do that. M, there you go, and then it's going to be x1 plus x2, we're going to put that over 2, and then on the other side, y1 plus y2, and put that over 2, and that'll be all. Okay, so let's go ahead and let's find it for our midpoint here for our x's. For our x's, we have x1, which we can say is negative 6, and we need to add that to our x2, let's say is 1, divide that by 2, and over here for our y's, we are going to have 3 plus y2, which is 0, and divide that by 2. Solving for this, you're going to have negative 6 plus 1 is going to be a negative 5 over 2. And solving for your y's, 3 plus 0 is 3, over 2 is 3 over 2, and that is actually your answer. So the midpoint of this segment is going to be at the point negative 5, 2, and 3 over 2, and then you're done. You can look in your book on page 28 for a picture of the graph and what this looks like, if you would like to see it. Here's one for you to try. You are trying to find the midpoint of these 2 points, where A is 512, B is negative 4, 8, and you are trying to use the midpoint formula to figure out where the midpoint of this segment is. So pause this video here and unpause it when you're ready for the answer. Alright, first thing we need to do is make sure we're using the right formula, the midpoint formula. So I'm going to take my x's and I'm going to add those together. My x's are going to be, here's x1, here's x2, so 5 plus a negative 4, that goes over 2. Here's my y's, 12 and 8, so that's going to be 12 plus 8, and put that over 2. And now I just need to simplify. 5 plus a negative 4 is 1 over 2, and 12 plus 8 is 20. I'm going to write this off to the side here. 20 over 2, and 20 over 2 can be simplified down to 10. So the midpoint of these 2 points is going to be at 1/2, so half a block to the right, and up 10. Okay, guys, I know we're getting pretty tired of this most likely. For this one, this is example number 5. Read the instructions carefully. It says find the coordinates of J if K, being at negative 1, 2, is the midpoint of JL, and L has the coordinates of 3, negative 5. So the difference in here, if you didn't catch it, is that we are already given the midpoint. K is negative 1, 2, and it's the midpoint of JL. L has the coordinates of 3, negative 5. So we're given an endpoint, which is L. We're given the midpoint, which is K, and we want the other endpoint, which is J. So what you see here is that I've already set up the problem. This is the midpoint formula, and we don't have x1 and y1 because that's J. But we do have x2 and y2, which is the coordinates from point L. And I've just put them into the midpoint formula. Over here, you'll notice that we have the midpoint coordinates, because when you use the midpoint formula, which is what this is, it will equal this. So here's the midpoint, and I put the coordinates over here. To solve this, you're going to break this up into 2 different equations. You're going to split it right down the middle. Equation 1 is going to help you do the x's. So let's do that on this slide. You have x1 over 2, I forgot to add 3, and all that should equal the x coordinate, which is negative 1. Now the only thing that you need to do is you have to solve for x1. To solve for x1, we're going to multiply each side by 2 to get rid of it, and we're going to be left with x plus 3 is equal to negative 2. Then we're going to subtract 3, we're going to subtract 3, and we get x equals a negative 5. So we know that J has an x coordinate of negative 5. Now we have to find its y coordinate. The same thing that we did, except with the y's. Here, I'm going to multiply by 2, and I'm going to have y1 plus a negative 5 equals 4, because I multiplied this side by 2 and this side by 2 over here. Now, I need to add 5, so I'm going to add 5 and add 5, and I'm left with y equals 9. So J has coordinates of negative 5, 9. And there, you've started from an endpoint and a midpoint, and you've gotten the other endpoint of a segment. Here's one that you're going to try to tackle on your own. You're given that P is the midpoint of line segment EG. E has coordinates of negative 8, 6, and the midpoint P has the coordinates of negative 5, 10. You by following the same method that we just did, need to find the coordinates of G. So pause this video, work it out just like we did the last one, and unpause it when you want the answer. Alright, let's see how you guys did. You have the formula up there that you need to use up in the corner, and let's plug in what we need to plug in. We do not have G, so we're going to leave that as x1. We do have x2. x2 is negative 8. So negative 8. We're going to divide that by 2. And what did you put that it all has to equal? It has to equal the midpoint x coordinate. In this case is going to be negative 5. From here, you're going to solve for x. So you can have x1 minus 8 is equal to negative 10. Then you're going to add 8, and you'll get x is equal to negative 2. So you have the x coordinate, you're halfway there. For the y coordinate, we're going to do the same thing. We know that the y1 we don't have yet. We do have y2, that's from E, that's 6. Divide that by 2, and the y coordinate has to equal of the midpoint P, which is 10. We're going to multiply by 2, so we're going to be left with y plus 6 equals 20. Subtract 6, you get y equals 14. And so our answer, G, has the coordinates of negative 2 from our x over here and 14 for our y. If you got that, great. If not, keep working at it. Write down some questions, figure out where you went wrong, and we can clarify that for you. This is example number 6, and I promise this is the last one. I knew this was going to be long, but bear with me because we're almost done. So example number 6 on page 29, let's do it to it. What this is wanting you to do is to find the measure of P to Q. So this part right here. And I apologize for the blurry picture. But we're not given what it is or what y equals. What we are told is that Q is the midpoint of P to R. So what that means is that these two, since it's the midpoint, have to be equal. PQ is equal to QR. And we are given those measurements. So what we're going to do in order to solve for y is we're going to set those equal to each other. 9y minus 2 is equal to 14 plus 5y. Now help me solve for y. You're going to subtract 5y, you're going to add 2, then this is going to cancel out, this is going to cancel out. You're going to get 4y is equal to 16. Divide by 4, you'll get y is equal to 4. Now, that's not what they wanted. They want you to figure out what PQ is. So to do that, now that you know that y equals, you can take it and you can plug it into 9y minus 2. 9y was 4 minus 2. 9 times 4 is 36, and you take away 2. Your answer is 34. So PQ is 34. All right. I'm going to stop there. There is the skill practice that you can click on, and the answers there should also be linked. So once you do it, you can check your answers. I hope you guys understood this. I hope I made it clear. If you have questions, write them down so you'll remember to ask, and I'll be more than happy to go over them with you. I will leave you with one last joke before I sign off. That joke: how did the barber win the race? He knew a shortcut. Alright guys, I hope you learned something. Once again, I hope it was easy. Try some of the practice problems out. Thanks for bearing with me. Thanks for sticking it through. Hopefully you took some notes and practiced the problems. And thank you for watching this, and we'll see you next time. Remember that you are special and that you're loved. See you next time.